On July 16, 1994, at a speed of approximately 60 kilometers per second, pieces larger than 20 meters in diameter collided with Jupiter, the largest planet in the solar system, in a single series. These chunks, each about 2 kilometers in size, continued to rain down on Jupiter for 6 consecutive days. NASA scientists recorded this collision with their special Hubble telescope. The impacts created scars that spread across the entire planet, so immense that they could be seen from Earth. This impact released more energy than 30 million nuclear bombs, heating the planet's environment to temperatures of up to 30,000 degrees Celsius. In 1994, the collision of comet Shoemaker-Levy with Jupiter marked the first such event in human history, observed through telescopes within our solar system, and its impact was recorded. For the first time, we witnessed the colossal impact of a celestial body on a planet, revealing just how powerful asteroid impacts can be. This was a space event, but in 2013, a similar impact occurred on Earth that shook the world. In Chelyabinsk, Russia, an asteroid, an object from space, exploded in Earth's atmosphere. The blast was more powerful than a nuclear bomb. Its shockwave was so intense that it was felt all the way to Antarctica. The explosion shattered windows in homes several kilometers away from the impact site. This 20-meter asteroid outshone the brilliance of the sun. Why are asteroids so powerful? Why are there millions of them in space? And why are they considered a potential threat to humanity in the future? Can we track them with our powerful telescopes and supercomputers? And if one were to approach Earth, what would happen? And how would we protect ourselves? To learn all these facts, let's embark on another incredible journey together that will change your perspective. In our solar system, there are currently billions of celestial bodies, ranging in size from 10 meters to thousands of kilometers in diameter. Among them, approximately 2.5 million are objects of about 10 meters in size, and about 1 million are asteroids of around 1 kilometer size. They orbit in our solar system. Let's explore this in more detail. In our solar system, there are currently millions of celestial bodies, ranging from 10 meters to over 1,000 kilometers in diameter. Among these, approximately 2.5 million are small objects around 10 meters in size, which are called asteroids. There are about 1 million asteroids around 1 kilometer in size. They are located primarily in the asteroid belt between Mars and Jupiter. These celestial bodies are potentially hazardous to Earth, and even a small asteroid can cause more destruction than a nuclear bomb if it were to impact our planet. Every year, Earth is hit by numerous small objects called meteoroids, which are also part of this population. So far, scientists have detected over 50,000 meteoroids smaller than 1 meter impacting Earth, indicating that our planet is not entirely safe from the impact of celestial objects. So how do these asteroids, which have the potential to cause havoc on Earth and other planets in our solar system, form, and why are there so many of them? Why do they continue to orbit in such large numbers? Can we track them with our powerful telescopes and supercomputers? And what would happen if one were to approach Earth? And how would we protect ourselves? To understand all of these questions, let's travel back in time to approximately 4.6 billion years ago, when our solar system was in its infancy. At that time, as the solar system was just beginning to take shape, dust and rocks collided and formed the building blocks of the early protoplanets. Heavier elements like iron, nickel, and iridium settled into the cores of these protoplanets, while lighter silicate minerals formed on their surfaces. Some of these protoplanets eventually grew into full-fledged planets, while others either collided with larger bodies or were scattered throughout the solar system as remnants. Today, these remnants can be seen as asteroids and other small objects that continuously orbit the Sun in various regions of the solar system. These objects can be classified into 3 main categories based on their composition. The majority of asteroids, about 75%, are made primarily of dark-colored carbon-rich materials. These asteroids are found in the asteroid belt, which is the region between Mars and Jupiter. Roughly 17% of asteroids are composed of silicate materials, and they are called S-type asteroids. They tend to be very bright and are relatively easy to detect with telescopes. Finally, about 10% of asteroids are metallic and are believed to have originated from the cores of protoplanets. These are known as M-type asteroids, and they are highly reflective and bright, making them relatively easy to observe through telescopes. Most of these M-type asteroids are found in the asteroid belt between Mars and Jupiter. Jupiter's massive gravity plays a significant role in shaping the distribution of asteroids in our solar system. Many asteroids collide with Jupiter and are captured by its gravitational pull, reducing the number of potential impactors on Earth and Mars. However, the region where asteroids pose the greatest threat to us is the Near-Earth Object Population, or NEOs. These are asteroids and comets with orbits that bring them close to Earth's orbit. Due to their smaller size and proximity to Earth, NEOs are more likely to be discovered using ground-based telescopes. They often appear as moving objects against a background of stars and galaxies. Scientists and astronomers regularly track NEOs to monitor their orbits and assess the potential threat they pose to our planet. While smaller NEOs can be tracked relatively well, larger ones are also of concern, as they have the potential to cause significant damage if they were to collide with Earth. These objects, orbiting the Sun, appear differently when processing multiple images together. Meanwhile, many stars and galaxies, located millions of light-years away, appear motionless to us. This makes it challenging to detect their territory and catalog all the asteroids. In our asteroid world, there are millions of asteroids that reflect only 15% of the Sun's light. Due to their small size and dark nature, detecting them is very difficult. Furthermore, tracking their motion and decoding their exact territory is highly complex. Unlike planets and stars, asteroids orbit at high speeds and can hide behind other objects. Therefore, we have limited data on them, even though we desire to track them. In 2013, the Chelyabinsk meteor was about 20 meters in size and had an explosive force of 500 kilotons TNT, making it 30 times more powerful than the atomic bomb that fell on Hiroshima. Imagine the power of larger asteroids. The destruction caused by any asteroid depends on its size and speed. If a 50-meter asteroid enters Earth's atmosphere at a speed of 17 kilometers per second and explodes, it can release about 10 megatons TNT of energy, which is significantly more powerful than Hiroshima's atomic bomb, by a factor of 600. However, the study I'm talking about, which enters Earth every 800 years, is not an immediate threat. In the asteroid belt, there are approximately 10 million asteroids larger than 1 kilometer. If even one of them were to approach Earth, it would pose a significant challenge. Approximately every 500,000 years, an asteroid of this size collides with Earth, releasing at least 47,000 megatons TNT of energy. This energy is equivalent to the combined power of all the world's nuclear bombs, multiplied by 10. The impact from such an asteroid could devastate an entire continent, creating a massive crater of about 14 kilometers in diameter on Earth. To avert such a catastrophe, an asteroid must enter Earth's atmosphere at a speed of at least 51 kilometers per second. However, 65 million years ago, the dinosaurs were not so lucky. At that time, a massive 10-kilometer-sized rock approached Earth at a speed of approximately 30 kilometers per second, delivering an impact equivalent to 100 million nuclear bombs, or about 16 septillion kilograms of TNT. The impact was so enormous that it created a crater of 300 kilometers in diameter on Earth, and the shockwaves reached speeds of 1,000 kilometers per hour, causing the atmosphere to heat up. Animals within thousands of kilometers of the impact site perished instantly. Within seconds, 95% of life on Earth was wiped out, including the dinosaurs, who disappeared forever. Although impacts of such massive asteroids are rare, every 50 million years, Earth experiences a similar event. So it's not just about tracking asteroids. It's about protecting our planet. I hope you enjoyed this special video from our side. Please like the video and subscribe to the channel. Thank you.